Hello friends, welcome to the second video of 12th Physics Animation series. In the previous video, we learned about what charge is and the electrostatic force caused by stationary electric charges. In today's video, we will discuss the classification of materials according to the behavior of charges in them. In our day-to-day life, generally, we come across two types of materials based on their atomic configuration. The first type of materials made up of atoms that are willing to leave the electrons in their outermost shell to get stable atomic configuration, even by absorbing energy available at room temperature. This results in the neutral atom splitting into a negatively charged particle, that is an electron, and a positively charged atom. This is why we find a negatively charged particle, that is an electron, which can move freely in the material, and a positively charged particle, that is an atom, in this type of material. In this way, many atoms come together to form a material. In a material, many atoms change into negatively charged particles, that is electrons, and positively charged particles in this manner. It would not be entirely accurate to say that all the atoms in a material can easily release their outer shell electrons at room temperature, although all the atoms in a material may be of the same type. Whether they can easily release their outer shell electrons or not also depends on how the atoms are arranged in the material and other parameters. The second type of material is made up of atoms that requires a very high amount of energy, more than what is available at normal room temperature, to release their outer shell electrons. As a result, these atoms cannot release negatively charged particle electrons from the atom. The entire material is made up of such atoms, and negatively charged particle electrons are not free in this type of material. It is important to note that both types of material are neutral, which means that the number of negatively charged particle electrons and positively charged particle protons in both types of material are equal. In the previous video, we saw that when a glass rod was rubbed with silk cloth, some of the electrons from the glass were transferred to the silk cloth, resulting in the glass becoming positively charged due to the dominance of positive charged particle protons. Conversely, when a plastic rod was rubbed with silk cloth, electrons were transferred from the silk to the plastic rod, resulting in an increase in the number of electrons in the plastic rod, and plastic rod will get negative charge. Let's now touch the positively charged glass rod to the left side of the first material and the negatively charged plastic rod to the right side of the same material. And let's understand how this material reacts. First, let's focus on the glass rod. When the positively charged glass rod is touched on the left side, the negatively charged free electrons present in the material will be attracted toward the positively charged glass rod. As soon as these electrons leave the material and move towards the positively charged glass rod, the material becomes positively charged due to the dominance of positive charged particles, protons in the material. In order to return to its neutral state, the material will attract excess electrons from the negatively charged plastic rod and continue to try to neutralize itself. Similarly, the positively charged glass rod will attract electrons from the material to fill its shortage of electrons and continue to take electrons from the material to make itself electrically stable. Now, if we observe carefully, we see that during this entire process, negative charged particle electrons are flowing from the plastic rod towards the glass rod. This means that electrons are flowing in the material. Materials that allow the flow of negative charged particle electrons within themselves are called conductors. And this flow of electrons is called electric current, which we will better understand in the current electricity chapter. This flow of charges will continue until the charges are balanced or electrostatic equilibrium is achieved. Copper, iron, aluminium, and impure water are some examples of conductors that allow the flow of negative charge particle electrons. The main reason behind this flow is the presence of free electrons in the material. Now let's move towards the second type of material. And in the same way, let's attach the positively charged glass rod and negatively charged plastic rod to its sides. As we can see in the animation, this material does not have free electrons, as the electrons are tightly bound to their atoms with the high force. As a result, the attraction force applied by the positively charged glass rod will not be able to pull the electrons, and if the electrons are not pulled, then positive charge will not be generated on the material, which means that the material will also not attract electrons from the negatively charged plastic rod. And we won't see any flow of negative charged particle electrons in this type of material. Materials that do not allow the flow of negative charged particle electrons are called insulators. Some examples of insulators include plastic, glass, rubber, and paper. Insulators can be charged by rubbing, but the charge will only remain in the place where it was rubbed, as insulators do not have free electrons. On the other hand, due to the presence of free electrons in the conductors, the effect of charge in the conductor can be observed anywhere in the conducting body. Apart from conductors and insulators, there is another type of material whose properties lies between those of conductors and insulators. It behaves like a conductor in certain conditions and like an insulator in others. This type of material is called a semiconductor. However, we will discuss semiconductor in detail in the semiconductor chapter. So that's all in this video. Thank you so much for watching.